The following slides were originally presented in my neuroscience class on the topic of using computers and computer algorithms in order to improve the effectiveness in learning. But first, let's take a look at what students are already doing to improve their learning. For example, highlighting a book as they're reading it, creating a pile of flashcards, or even using a mnemonic to remember a list of items. So, why do we students use these techniques? Well, yeah, they seem to work, but how do we know they work, and how can we test them? It's really more difficult of a problem than it sounds like. And in order to answer, we're going to have to take a look at a pioneer in the field by the name of Hermann Ebbinghaus in 1885. He was a psychologist, and he tackled these problems by using nonsense syllables as a metric to measure retention. And one of the most important things he noticed was that long study sessions were not as effective as short ones. And in noticing this, he laid the foundation for the importance of temporal locality, or timing, within the context of learning. More recently, we've developed what's called the primary recency effect, or the serial position effect. Essentially, it predicts the retention during a session will be broken into three distinct groups: the first prime time, the downtime, and the second prime time. The first prime time is best for retaining information. The second prime time is good, though not as good as the first prime time. And the downtime is noticeably worse than any of them. There are many different experiments to demonstrate the primary recency effect, such as if you are given a list of 20 words to remember, you will remember most of the words in the beginning, some of the words in the end, and probably much fewer words in the middle. But what's really interesting about this is that as the study session grows longer, the relative size of the downtime increases. If you look at the chart on the right here, you'll notice that in the 20-minute session, the downtime was only about under 20%, whereas by the 80-minute session, the downtime has grown to a third, if not half, of the entire study session, which gives us a good insight into why long study sessions seem to be overall less effective. But now let's take a look back and look at our different types of memory. First, we have short-term or working memory. And there's a very famous sort of formula called 7 plus or minus 2 chunks of information in the working memory. Now, this number has kind of been tweaked and filled with since it originally was presented, but the basic concept is that the amount of information that can be stored in short-term memory is fixed. Now, this is interesting for us because we shouldn't be considering items that are only in the short-term memory and not in the long-term memory as remembered. So in other words, only items which are encoded in the long-term memory are considered to be memorized. So within the context of this, consider a phone number, for example. You can recite a 7-digit phone number over and over and over again, but as soon as you stop reciting it, you probably won't remember more than a couple digits. It's not encoded in long-term memory, it's in your working memory or short-term memory. Related to this concept is the articulatory loop rehearsal system. It's part of one of the models of how short-term memory works, and it suggests that the faster we can rehearse a sound, the more we can store. And it also points out that the longer it takes to read a word predicts how well it will be remembered. So essentially, this is one of the first hints that we have that we should be using essentially a small bit of information rehearsed very quickly and then moving on without sitting there and mulling over the same information over and over again. We'll come back to this later. But first, let's take a look at also long-term memory. When we take a look at long-term memory, there are two very important factors we have to consider. The first is activation, and the second is strength. Activation is not really surprising on the surface because it says that essentially items which you have remembered somewhat recently are easier to remember than items which you have not looked at in a long time. But what is surprising about activation is that this benefit spreads to related concepts. For example, if you start reciting colors, red, blue, green, then it's much easier to come up with other colors because they are linked conceptually. And functionally speaking, this seems to make sense. If we're working on something, we want to be able to remember related topics. We want to be able to call that information up to mind because it's what we're focused on at the moment. So the other important factor of long-term memory is that of strength. Now, strength essentially translates to the amount of practice when working on something. once the positive benefits of activation are gone, the retention of the object in question and the fact in question is based almost entirely on how much practice you have. However, there's also an impact from the depth of processing, or in other words, how well you understand something. But ultimately, what we're looking at here is that strength is what we really want to improve when we're talking about long-term memory and memorizing anything. But one of the unfortunate things is that strength essentially suffers from the law of diminishing returns, which is to say that the more you study, the less the effectiveness of the studies. So essentially this means that at the beginning, each time you practice a fact that you don't know, you're gaining a lot. But once you understand it at a very high level, then any additional practice is relatively less effective. So one other interesting point about long-term memory is that the vast majority of forgetting occurs immediately after learning, which is to say even just a few seconds after learning something. If you're going to forget it, chances are you already have. Okay, so now that we've taken a look at the basic types of memory and some of interesting facts about memory, let's take a step back and look at some of the bigger picture here. We're starting to get to the idea that we should have small bits of information rehearsed quickly. This also helps to link bits of information together, because when you have small bits of information, you can start to see the connections between them. Just for example, the concept of Chinese characters. When studying the Chinese language, it can be very important to see when one character is used in a different word and how these two words might be conceptually linked. And this is easier to do when you see the words somewhat close together. And we should also not count items in the short-term memory or recently activated as learned. So this is to say that anything that has been recently accessed is given a sort of artificial boost in terms of our learning. So we're starting to see that temporal locality has a large impact on how well we remember things. So this kind of implies that we might be able to use some sort of algorithm to describe timing.